Emostel.
Hello, welcome to another video, still on this series of error analysis. All right, okay, in this particular video, we are just going to, talk about error propagation. Okay, so propagation of error, like how we can manage this error of a thing in the process of addition and subtraction. You see, there are some formulas that I'm going to use in this video. You don't need to ask me how the formula was gotten, because even in the PHY191 course material, it was stated clearly that the whatever is it that is behind the generation of the formula and all of that is beyond the scope of the book. So if it is beyond the scope of the book, I too would not even bother going there. Just like the way we found the precision index, the formula for the precision index, that's by d over root n. Why is it like that and all of that? So no explanation, but then the formula was given. Okay, so because at this moment, you don't really need to care about that. Okay, that is not really what you should so much bother about. But when you get to the stage where you are doing some form of advanced physics, especially physics students, then they may really go into the depths of how those things were formed. Okay, so we have some formulas that we are going to be playing with in this video. Okay, I'll just go straight to the point, indicate the formula, then to tell you that, okay, whenever you have this kind of situation, this is the formula to apply. Whenever you have this formula situation, this is what you apply. And then you get it done, and then you are settled, okay? All right, so let's quickly get back to work. Now, in this question here, you have been given a particular measurement. Remember in the previous video, we arrived at a measurement in which, and then the precision index was used, okay? So let's say this happens to be the precision index for that particular measurement, okay? And then this is the average value of the measurement. So now we took measurement of another length again in meters, and then we got this as the precision index or as the maximum possible error, okay? And then we got this as the average value of the measurement, okay? Now, if there happens to be a situation whereby we are required to add these two measurements, please don't make the mistake of adding these two things directly and adding these ones directly. It is not done, okay? So physics and mathematical physics makes us to understand that to get rid of this kind of situation, to solve this kind of question, you are going to apply a particular formula to get it done. It is not direct addition. It's just like vectors too. You don't add vectors directly, but rather you do the sum of the squares of the component of the vector. Exactly that kind of stuff is what is going to happen in this case. Now, if anything is adding directly, the part of it that will be adding directly is only the average value. But apart from the average value, the error part of it will not be adding directly, we'll be applying formula to do so. All right, so the formula for this thing is that if let's take L as for instance now as the actual measurement. Let's take L1 as the actual measurement, and we are going to assume we are going to represent the error part with a delta symbol, okay, as DL1. So which means that L is 1 point, so that is to say 1.746 is L. Meanwhile, the error part is what? 0.010, okay? I'm just like showing you this L plus the L and all of that, okay? So if you have the average part as L and you have the error part as the L, okay? And then you have the second one too, okay? We have the second one to L2 plus or minus delta L2, okay? No problem. If you are to add them, all right, you will see that the sum or difference, even though it is plus, whether it is plus or minus, the place that plus and minus affects is this main value. So if it is minus, if you say L1 minus L2, you say this one minus this one. But these ones here, you have a formula to apply. I'm trying to arrive at the formula. So if it is addition, you add these two, but you apply this formula to sort out these parts. The formula is the same for handling these parts, whether you are adding or subtracting. The formula is the same for handling these parts, whether you are adding or subtracting. And that formula is like the error part of it alone. You are going to use the formula which says the square root of dl1 squared plus the square root of dl2 squared. That is what you are going to do. Then this one will now be like L1 plus L2, okay, plus or minus the result of this one. That's how we are going to do it. Which means the average of the average part of this, which is the average measurement here, which is this one in this case and this one in this case, okay, you are going to add them. And if the question wants you to subtract L1 from L2, you subtract them, no problem. But the addition and the subtraction only affects these parts. But for these parts, whether you are adding or subtracting, this is the formula you apply for the error parts. Whether you are adding or subtracting, the formula for the error part is the same. But this one is what the addition or subtraction will only affect. So in this question now, we are asked to add the two of them. So for the addition, you now say, therefore, the total, which is the addition of the two of them, is going to be equal to what? L1 plus L1 plus L2. So L1 plus L2 actually is going to give us like 1.746 plus 1.507. Okay? And then that part is going to be what? 6 plus 7, that is 13. 3, 1. Okay? So 1 plus 4, 5. 0, that's 5. Then 5 plus 7, that's 12. 2 remaining 1. Point. 1 plus 1, 2 plus 1, 3. So we have 3.253 for the value of L. Then we now have the value of delta L will be equal to what? The delta part of it, the error part of it will be the sum of the squares of the possible error or the precision index. So that is going to be like the square root of 0.010 squared plus 0.010 squared. All right. So if you find the square root of these two, so what is it going to be? I need to use my calculator. Sorry. Okay. All right. So 0.01 raised to power 2. There is square here now. Okay. Times 0.01 equals this. So we have 0.0001 plus 0.0001. Okay. So we have this, and then that would be the square root of 0.0002. So which means the error parts will be equal to the square root of that. Okay. Square roots of of 0.0002. The square root is going to be 0.014. 0.014. So that's going to be the square root of this result here. Okay, so remember when we were adding, we had 3 decimal places. I think we have it in both cases too. So they are the same. The stuff that we are adding is the same. So when we took the square root, okay, and all of that too. So the answer, our answer too, we'll keep it at that level. So we have our D as 0.014. So in that case, our final answer after taking the length is going to be equal to what? So therefore, L is going to be equal to the average. What's the sum you got earlier? The sum we got earlier is 3 points. So you have 3.253 plus or minus 0.014, all in meters. So that is the answer for that. So whatever is it that we did here, what we did here is just that we have this value, the actual value, the error value, the actual value, the error part. Then we said L1 plus L2. We add these two together. Then we took the sum of the squares of these two, and then we joined them. So that is all. If it was subtraction, you subtract them from each other, take the sum of the squares of this one, and then you join it, and then that is all. So that's how you run it. Okay? So that is for addition and subtraction. The case for multiplication or division is different. All right. So in that case, you are going to apply the one for the product rule and all that. So let's quickly go to that. We want to calculate the fractional error. In this case, now, you know, the first one that we did was talking about the one for addition and subtraction. So the one we are going to do now is talking about the one that caters to multiplication or division. How can we calculate the error, or how can we do the error propagation when we are dealing with quantities that are adding, that are multiplying or dividing? There is a formula for this, okay? The formula says that, in fact, there is a law. The law just makes us to understand that the fractional error of the fractional error of two quantities that multiply or divide, okay, is equal to the sum of the squares of the fractional errors of the sum of the product. I'm sorry, the product or the quotients, like the two things that are dividing. Okay, let me just explain this way. It's like if we have E, let's say we have a quantity E is equal to AB, or maybe we have a quantity E is equal to A divided by B. All right. So quantity E is equal to quantity A multiplied by quantity B, or E is equal to quantity A divided by quantity B. Whether they are multiplying or whether they are dividing, the same law applies. The law states that the fractional error in E is given as delta E, okay, over E, is equal to the sum of the squares of the fractional error in the product, okay, or the quotient. All right. So which means we are going to have like the sum of each factor present in the product of the quotient. Okay. So the fractional error. I'm trying to figure. The English is somehow, but it is just simple, straightforward. Is that the fractional error when we have two quantities multiplying each other, that the fractional error is given as the sum of the squares of the fractional error of the factors. Okay, so we are going to say that the fractional error in E is going to be equal to the fractional error in A squared, the square root of the fractional error in A squared, plus the square root of the fractional error in B, all squared. So this is the formula you would apply. All right, it works for whether A and B are multiplying or A and B are dividing. The same formula applies. All right, and the thing that is the subject of the formula too is what is going to. That's the only thing that escapes from the square. Okay. All right, so we are going to apply that because we know that velocity is equal to what? Change displacement over time. Velocity is equal to displacement over time. We know that, right? Good. And then, as you can see in the question, they've given us the displacement and its error as 0.63 plus or minus 0.02. meters. And the time and the error too, okay, has been given as 1.71 plus or minus 0.10. Okay, also in meters. All right. Now, in that case, we are going to carry out some major assignments. The major assignment is that we are going to first find so in this case now, it's like E is our V, A is our S, and B is our T. That's the way it looks like now in this case. So if that happens, then you have this one as del S over S. Del S over S is going to give us something like, what is del S? What is the error? It's 0.02 over S, which is 0.63. All right? And then we are going to get that. I need my calculator for that. Okay, 0.02 divided by 0.63. Okay, the result is 0.03. Okay, remember that the two of them have equal precision, they have the same precision. Although, so you are going to go for the number of significant digits in the one with the least number of precision, but so in terms of number of their precision, they are the same, but this one has the number of significant digits that we have here is just one. So your final answer too will be what? Will be having that one significant digit, which is this. So you stop, the answer is longer, but you stop at the one significant digit, and that is the result for this. Then we do the other one, del T over T. Del T over T is going to be like 0.10 over T. So what was our T? 1.71. So that will be equal to 0.1 divided by 1.71. All right, 0.10. I just want to be sure that we're on track. 0.1. So this one is going to be 0.06. That's what we got here, 0.06. Okay, all right. So, although this one has two significant digits, this one has 3. Okay, and then after division, then we got this result. Okay, but then what is the precision of it? The precision of the one with this is what? Is 2. So just keep the answer 2 as 2. So you're going to leave it that way. And then this one also is going to be left that way. And then we are good to go. All right. So the next thing we do in this case is to square each of them. Okay. Like this. So maybe we should just go straight to the point as del V over V is going to be equal to the square root of this one squared, 0.03 squared, plus 0.06 squared. All right? And so 0.03 squared is going to be 0.03 times 0.03. Yeah, that's going to be equal to the square root of 0.0009 plus 0.06. Calculator here doesn't know your square. Okay, raised power 2. Yeah, we have 0.0036. 0.0036. So adding them, 0.0009. So we have the square root of 0.0045. Okay? So del V over V is the square root The square root of 0.0045 will be equal to, you have 0.07. So, all right, 0.07. That is del V over V. Please just follow me. Okay? Del V over V as 0.07. Now, the question says we should find the fractional error in V. We have already gotten the fractional error, which is this answer. This is the result for the fractional error in V. But just in case we want to represent V the way this one and this one are represented, it's quite easy. So what you're going to do is that we need to find what the actual V is. You know the actual V is not given in the question. So actual V, okay, actual V is equal to displacement over time. And then, so we are going to use the actual S over actual T, which is 0.63 over 1.71. And so that is going to be like 0.63 divided by, divided by 1.71, and then that's going to be equal to 0.37. That's for actual V, okay? Actual V is 0.37, all right? So we know that del V over V is equal to 0.07, right? So it means that del V is going to be equal to, that's when you cross multiply. This times this is equal to actual velocity multiplied by 0.07, right? So in that case, del V is equal to, the actual velocity we just got now is 0.37 multiplied by 0.07. So del V is going to be equal to 0.37 multiplied by 0.07 is 0.03. So that's the answer for del V. So having all of these things already now, you have your dV, you have gotten your dV. So which means that V plus or minus delta V, just the way the other ones have been written before now, is going to be equal to the actual velocity, which is 0.37, plus or minus the delta V, which is 0.03. And so that's the final answer. That's the representation if you want to represent it the way the other ones are represented here. And so that's just it. Okay? So I really hope you understood all of this. All right? If you have any question or there is something that is not clear to you, please feel free to ask me. You can send me a DM through the number that flashed on your screen during the course of the video. You can also send us an email. Even if I don't have the time to attend to you, you have a lot of people that will attend to you in our team, and everything will be clearly explained to you, okay? All right, and then also, please, I really won't have to stop here because of time factor, okay? I really have to stop here. So what I want to do now is that you should apply the knowledge, all of these things that you have learned, so far in the course of the video, go back to your course material and apply the knowledge. So I'm sure you'll be able to understand what is written there right now, as in by now. And then solve the questions that you have in your course materials with your own examples, as in with the knowledge of what you have gotten here, then follow through with the questions in the course material in their own example, solve it, and then see whether the same answer you got is what they also got, okay? But above all, if you have issues at any time, please feel free to contact us, and then we'll be able to attend to you and sort you out. All right, so don't forget the four stuff that holds our that we stand upon in Emostel Academy. We believe in your learning. We believe in your understanding. We believe that when you learn and understand, then you should be able to put it into practice, so that you don't forget what you got to learn. And also you can use it to solve some real life situation. All right, and then, because that's the essence of education in the first place. And then when you learn, when you understand, and then you've been able to practice what you learn, excellence is not far from you, because excellence becomes the result. See you at another time. Bye.